Assalamualaikum student, welcome to the e-classes of S.Sci English High School. This is Shazia Khan, subject teacher of SST. Today I am going to teach to standard 7 geography chapter number 3, that is tides. So let's start with the explanation. Geographical explanation. Both the photographs show the same place. If you stay near the coast for some time, you will realize that the sea water is sometimes very close to the coast. Figure 3.1a, while at other times it is far away from the coast. Figure 3.1b, we call this movement of the sea water tides. Bearing a few exceptions, all the coast on the earth experience tides. High and low tides are natural phenomena. Let us try to understand the scientific reason behind these natural events. Tides are movements of a sea water occurring daily and regularly. The level of sea water changes after a specific period of time. After every 12 hours and 25 minutes, a cycle of high tide and low tide gets completed. This regularly occurring event appears to be quite simple and natural. However, it is directly related to the sun, the moon, and the earth, and the gravitational and centrifugal forces that interact between them. What this paragraph means? This paragraph means sometimes the sea water is very close to the coast and other times it is far away from the coast. This natural phenomena is called high tide and low tide respectively. Bearing a few expectation, all the coast on the earth experience tides. Tides are movement of sea water occurring daily and regularly. The level of water changes after a specific period of time. After every 12 hours and 25 minutes, a cycle of high tide and low tide gets completed. Now, since the regularly occurring events of high tide and low tide appear to be quite simple and natural. However, the tides are directly related to the sun, the moon, and the earth, and the gravitational and centrifugal force that interact between them. Now you can try this. Keep a small stone or a chalk piece on your notebook and move the notebook from left to right with some force. Take water in a small container which has a handle. See what happens if the container is whirled around with force. Fill the mixture jars with water and switch on the mixture. Observe. Do this under the supervision of parents. Observe a fan and a slingshot while they are moving. Okay. Observe a fan and a slingshot while they are moving. Take a half glass of water. Slowly move the glass in one direction in circular fashion. Observe what happens to the water. Observe what happens if you whirl a key ring around a figure. See, the pictures are given here. This boy is moving the glass with water and the girl whirling the key ring. Okay. On the basis of the question given below, discuss the result of the activities listed above. In which direction did the piece of chalk fall? You have to solve this question on yourself. Now, geographical explanation. In all the above activities, the effect of the centrifugal force is visible. The centrifugal force act in the direction opposite to the gravitational force. Centrifugal means going away from the center. You must have experienced it too at the local fairs. If you sit in a Ferris wheel, your seat spins, leans outward away from the wheel. Away from the wheel. This also is an effect of centrifugal force. Now divide the student into two equal teams. Conduct a game of tug of war for 5 minutes. Discuss their experience in the class. Now student, you can do all these activities on your home. Take a partner of your take a group of 2 or 4 people and do these activities on your home. Now centrifugal and gravitational force. Due to its rotation, the earth gets a type of power or force. This force work away from the center. It is called centrifugal force. See figure 3.5. Due to this force, any object on the earth would be thrown into the space. However, the gravitational force is working toward the center of the earth at the same time. This force is many times greater than the centrifugal force. Hence, any object on the surface of earth remains at the place where it exists. See, you can see figure 3.5, centrifugal force and gravitational force. The centrifugal force, the power or force that the earth gets due to its rotation is called centrifugal force. This force works away from the center of the earth. And the gravitational force is that due to the centrifugal force, any object on the earth would be thrown into the space. However, the gravitational force is working toward the center of the earth at the same time. Due to the gravitational force, any object on the surface of the earth remains at the place where it exists. Now, the tides. The following factors are responsible for the occurrence of tides: the gravitational pull of the moon and the sun as well as that of the earth. Revolution of the earth around the sun and the indirect revolution of the moon around the sun. Centrifugal force generated due to the rotation of the earth. See figure 3.6 is given here. Occurrence of tide. The moon is closer to the earth than the sun, hence its gravitational force becomes more effective than that of the sun. Tide occur due to the relative position of the moon, the sun and the earth. A place on the earth located at the opposite point of the place experiencing high or low tide also experience high or low tide respectively at the same time. This is a result of centrifugal force. See figure 3.6 and try to understand the location of high and low tides on the earth. See, when the moon is closer to the earth than the sun, hence its gravitational force become more effective. Tides occur due to the relative position of the moon and the sun and the earth. Whenever you see the figure 3.6, at the same time tides respectively at the same time high and low. So you can understand from this diagram When there is high tide at 0 degree meridians, the 180 degree meridians also experience high tide. When you realize or experience 0 degree meridian, so at the same times 180 degree meridian also experience. The meridian that are at right angles to those having high tide will experience low tide at the same time. See what it is saying, that the meridians that are right angles to those having high tide will experience low tide at the same time, means high tide and low tide experience at the same time. If it is high tide at 0 degree and 180 degree meridians, then at which meridians will low tide occur? Okay student, now go to the next paragraph. Types of tides. As the timing of the tide varies every day, the range of the tide also keep on changing. As the type of tide varies every day, range of tide also keep on changing. Generally, the highest high tide occur on full moon day and new moon day, whereas on the days of the first and the third quarter, the high tide is at its minimum. Spring tide and neap tide are two types of tides. When generally the highest tide occur on full moon day and new moon day. On the day of the first and the third quarter, the high tide is at its minimum speed. There are two types of tides, spring tide and neap tides. So let's start about the some information. Spring tide. On new moon day and full moon day, the gravitational pull of the sun and the moon act in the same direction. Due to this, the total pull increases. Hence, the tide on these days is much higher than the average high tide. This is known as spring tide. See figure 3.7. As the bulk at the high tide is greater, the water at low tide recedes much more. The water level during spring tide is higher than the average high tides and lower than the average low. Now spring tides. On the new moon day and full moon day, the gravitational of the sun and the moon act in the same direction, leading to spring. Spring tides are higher than the average high tides and lower tides than the average low tides. Now, neap tides. While revolving around the earth, the moon makes a right angle with respect to the earth and the sun twice a month. This position occur on the first and the third quarter of each month. On both these days, the forces of both the sun and the moon operate at right angle on the earth. See figure 3.8. See figure 3.8. At the place where the sun causes high tide, the gravitational pull of the moon, which is at right angle, also act on the seawater. Due to such conditions, the water level rise is less than usual at the time of high tide. So on the first and the third quarter of each month, the forces of both the sun and the moon operate at right angle on the earth, leading to neap tides. Neap tides are a little lower than the average high tides and higher than the average low tides. Okay student, so it is enough for today. We will continue in the next video. Take care and thank you.